All right, there you missed a bit, Jenna. Everyone want to say hello to Jenna? Oh, that's beautiful. And is Chanel not here? Yeah. And Chanel, yeah. We miss you too. They're not just favouring Jenna. It's like, I haven't done the roll yet, to be fair, so there could be someone else missing as well. Oh, and there is. Where's Lewis? Yeah, all right. Yeah. So hi, Jenna and Chanel. Write down the first. We're doing number sequences, chapter 2. They're really easy. There's the first question. I think you can figure them out. Question 2. For each of the following, write a description of the sequence and find the next two terms. Anyone want to pick A, B, or C to do? Okay, let's do C. I don't think we need to do all of them. So C it is. Describe the sequence. Start at what? And then, oh, it's for the best movie ever. Yeah, Dude, Where's My Car? It's the funniest movie. Yeah. How about mine? Dude, what's mine say? That's funny. And then subtract 5 to get to the next term. And so to find the next two terms, we're at 21, and we'd subtract 5 to get, and then subtract 5 again to get 11. And we could continue that on forever. Very exciting. That's it for 2A. Okay, number sequences. We could do something out of describe the following number patterns and write down the next three terms. Oh, I'll do that only because it's got two important sequences that you guys are supposed to know and don't. 2 out of these 3 are important ones, and I told you to learn them once, and you didn't. Well, maybe you do. You tell me. Which of these 2 sequences are really important and you should know? First one, yeah, what is it? Yeah, square numbers, so we should be able to just keep doing those, shouldn't we? And what's the next one? Cubes, good. There we go. Yeah, so start at 1 and square each number, like add 1 and then square it to get the next one. Or you could, interestingly note, that's how you could find that the difference between squares is an odd number and they're just increasing by 2 each time. So the first difference between the first 2 is 3, the next 2 is 5, the next 2 is 7, etc., etc. Cubes are a little bit more complicated, but that's it. There's nothing too exciting to see there. We probably won't ask you anything exactly like that, so let's not get too carried away. Here they're just introducing a bit of notation. Now, I don't even know if we do that in our little semester outline, so let's go back and check. 2B. Is 2B in our little outline? Oh, it is. General terms. Okay. But it's, again, it's so short that we're going to be done within the next 5 minutes. So in this case, we'll snip this into our notes so we've got it there. A general term. Sometimes we use U or T or TN. Little subscript refers to which one you're up to. So we'll have a look when I paste it in here. That didn't work. Try that again. Post it down the bottom maybe would help a bit more. There it is. So the little subscript in each of those, UN, TN, little tn and AN, A for arithmetic maybe. The N stands for what number in the sequence you're up to. Like the third number would be T3 or U3. The fifth number in the sequence would be U5 or T5. That's all they're saying there. So UN represents a sequence that can be generated by using UN as the nth term. UN is a function, blah, blah, blah. For example, 2n plus 1 generates a sequence. So you start with a number 1 and you get 2 times 1 plus 1 is 3. Then the second term would be 2 times 2 plus 1. Which is how they got to 5. And the next term was 2 times 3 plus 1, which is how they got to 7, etc. So we'll do a couple of these just because we can. So we'll start with a nice easy one. 1a, if a sequence is to follow 2 times n, then when n equals 1, what would the first term be? 2 times 1 would be 2. The next one, 6, 8, 10. Pretty easy, hey? Let's try F just to make sure we know what we're doing. Oh no, let's try, oh, I said F now. I was going to do G, but too bad. 2n plus 11. So when I substitute in the number 1, I get 2 plus 11 is 13. When I substitute in the number 2, I get 2 times 2 is 4, plus 11 is 15. 2 times 3 is 6 plus 11, 17, 19, 21, etc. You can see really clearly and easily how that's going to work. Let's try H, 4n minus 3. If I want to do a sequence where I start with n equaling 1, then my first number is going to be 4 times 1 minus 3 is 4 minus 3 is 1. Fair enough. My second number, 4 by 2 is 8 minus 3, that'll give me 5. 4 3 is a 12 minus 3, 9. 13. You can see it's just going up by 4 each time. Why does it make sense that it's going up by 4 each time? Because you're adding an extra multiple of 4 each time as you go. So we're expecting to see something like that. Yeah. No. So it's saying you let n equal, so it's going n equals 1 is going to give me 13. N equals 2 for the second term will be 2 times 2 plus 11. Yeah. So it's not doubling the previous one, it's just 2 times whatever number you're up to. So that'll be 15, 2 times 3 plus 11 would be 17, etc. Yeah, cool. Let's have a look at question 3, just because it looks like more fun. List the first, what do you want to do 1 from 2 first? All right. I wanted to save you some fun and work for yourself, but let's just do it. Pick one out of 2 for me then. Go on, Dobbo. Oh, A is really easy. 2 to the power of n. So the sequence I'm going to get is 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, 2 to the power of 4, 2 to the power of 5, isn't it? So it's really just 2, 4, 8, 16, 32. You're getting a little sidetracked, guys. Too many little conversations. Should be easy. So I'll have a go at C. 6 multiplied by a half to the power of n. So for this one here, I'm going to have 6 multiplied by a half to the power of 1. The next number would be 6 multiplied by a half to the power of 2. The next one would be 6 by a half to the power of 3, because it's the third term. The fourth term, 6 by a half to the power of 4. Fifth term, 6 by a half. Just a bit more room. To the power, go away. It doesn't want to go away. There you are. To the power of 5. And that would continue on as well, wouldn't it? So 6 divided by 2, that's going to be 3. You can see I'm just dividing by 2 again, so we get 3 over 2, 3 over 4, 3 over 8, 3 over 16, etc., etc., etc. You just keep going on. They're not. Do they make sense what they mean, that notation? I wanted to try one which had a negative number in it, just so you can get the feel for what happens when you have a negative being raised to a power. So we'll do question 3, just for something a little bit different. That's nearly big enough I can see it now. List the first 5 terms. So I would start off by just listing them with the number 1 in the first term, it's number 2 in the second term, and go like that. So there's 1, 15 minus negative 2 to the power of 2. 15 minus negative 2 to the power of 3. 15 minus negative 2 to the power of 4. 15 minus negative 2 to the power of 5. So I heard a little birdie saying, is n just 1? N is the number of the term in the sequence. So in the third term, n is 3. In the seventh term, n is 7. In the first term, n is 1. Yeah. So Bella, you got it? Like n is just the number of the term. Like if it's the fourth term, n is 4. Yeah, okay, cool. So this one here, then you just go ahead and clean it up. So that's negative 2 to the power of 1 is negative 2, so that becomes 15 plus 2, 17. Negative 2 squared is 4, 15 minus 4, 11. Negative 2 cubed is negative 8, so it'll be 15 minus negative means 15 plus 8, 23. Negative 2 to the power of 4 is 16, 15 minus 16, negative 1. Negative 2 to the power of 5 is negative 32, so it's going to be 15 minus negative means 15 plus 32, 47, etc. Oh, we probably won't, like, realistically, we probably won't even do ones like this. We'll move on to the more specific ones, arithmetic and geometric ones, which we're about to see. But maybe I'll give you 5 minutes to say, just go and do the rest of those questions in 2A and 2B, so we knock them off. Are people actually going to do them, or are they going to go back to wherever they were up to? Well, we just did enough of them. We can just keep going if we'd rather. Which one? Ah, because negative 2 to the power of 4 is positive 16. 15 minus 16, negative 1. My kid, he had it for breakfast, so they had training at 6. Yeah, he had a McMuffin, sausage McMuffin, and a hash brown. Outrageous. And so the 11, the second term, so negative 2 when I square it is positive 4, and that's just 15 minus 4, 11. Yeah, we can. I'll put the working in between maybe. So if you wanted to, we can have this line of working in there as well. I'll just put it. So that would equal 15 minus negative 2, which just becomes 15 plus 2 is 17. The second one would become 15 minus, and negative 2 squared is positive 4. So 15 minus 4 is 11. 15 minus negative 8, so it becomes 15 plus 8, 23. 15 minus negative 2 to the power of 4 is positive 16. 15 minus 16, negative 1. 15 minus negative 32. So negatives make a positive. If you take a negative number and raise it to an odd power, the answer is negative. And if you raise it to an even power, the answer is positive. That's, now I see what you're getting at. Yeah. Why are you searching Crunchy? Not unless you... Because it's maths? That's why not. Special sorts of sequences. Don't do that to me. Well, that's a good idea. Really? So I could get that for lunch. That would be so unhealthy. What I want to know, are there any borders here? No. Chanel's a border, isn't she? It's a pity because they had calamari and they had a whole truckload left over and I would have just eaten it. What border's got calamari for like morning tea? And there was a whole massive mountain of it left over. Why did I not get to eat it? Oh no. I was disappointed. Alright. Yes, the word on its own, arithmetic, is the noun, but this is a type of sequence, so it's describing the sequence, so it's an adjective, and it's an arithmetic sequence. So it's not an arithmetic sequence, it's an arithmetic sequence. An arithmetic sequence is a sequence in which each term differs from the previous one by a fixed number. So you are either adding or subtracting a constant amount to get from one term to the other term. So you remember that arithmetic is like adding numbers together, so that's what we do. So that's what they're saying here. The difference, un plus 1 minus un. So let's take any term and subtract the term in front of it and you get D. You get the difference between the terms, and it should always be the same. So, for instance, in the first one there, 2, 5, 8, 11, 14, common difference of positive 3. The difference between the terms is 3. In the second example, 31, negative 27, 31, 27, 23, 19, decreasing by 4 each time, so the difference would be negative 4. Nothing very exciting there. Let's see. Whoa, general formula. You'll come up with this yourself anyway. If I want to find any term in the sequence, all you have to do is figure out what number you are and just take the first one and add the difference, one less than whatever term you're up to. But we'll get to that. Well, we'll do an example, that'll help. Yeah. Oh, really? Stop making me hungry. Make your own Macca's burger. Well, yesterday I got a burger from the fish and chip shop up the road. Tipplers, so good. Hey? Tipplers is awesome. It's so good. Their burgers are awesome. Burger with a lot, $9, and you get, it's so nice. You would need like half a one, maybe. Interesting. That's crazy talk. Anyway, back to our maths, because Jenna doesn't want to hear about all the Maccas we're not eating. And Chanel doesn't want to know. Although I wonder if Chanel got the calamari. Should have saved us some. Alright, consider the sequence 6, 17, 28, 39, 50. Show the sequences arithmetic in nature. Let's have a look. U2 minus U1. So the second term minus the first term is 17 minus 6. What does that equal? 11. There we go. What about if I did the third term and took away the second term? 28 minus 17. Ah, the difference is 11. If I continue doing that, U4 take U3. 39 take 28. 11, the fifth term, minus the fourth term. So if you just take one term and subtract the term before it, if the difference is always the same, this is an arithmetic sequence. Because they differ by 11 each time. Yeah. Two consecutive terms, yeah. The difference, for it to be an arithmetic sequence, the difference has to be the same answer every time. Yeah. Find a formula for the general term. So what they're asking here for is, how would I figure out so what they're trying to figure out now is, what's a rule to find any term? So if I wanted to know the 13th term of that sequence, without having to find the 12 in front of it, how would I do it? Well, pretty easily, and I would take the first term, whatever the first term was, which in this case was 6, and then I would have to add on 11 how many times? Well, to get to the second term, I add on 11 once, don't I? To get to the third term, I added on 11 twice. To get to the seventh term, I'd add 11 6 times onto the first one. So to get to the nth term, I add on the difference n minus 1 times. So that's our general rule, and that's what we've got just above there in blue. You can still see it's up there. So now we're just subbing the numbers. What was the first term? The first term was 6 plus n minus 1 multiplied by the difference between terms is 11. You're using the window as a light box. Very classy. Fair enough. Is that because you have to go to the dentist then? Is that because you have to go to the dentist at 2:30? I don't know about what. At 2:30, because that's what time you have to go to the dentist. He's got it there. Yeah. Oh, my 2:30. I have to go to the dentist. Yeah, but you are. Oh, as if you're not going to watch this back, Dougie. Go on. Yeah. You can subscribe to my YouTube channel. It'll be amazing. All over it. All right, Dobbo's back with us. What are we doing? All right. Okay, so I'll talk you through it again. So to get to... Because in part A, what was the difference between each of the numbers? So the first two bits are just like... That's the general rule, okay? U1 is the first term, which was 6. That's the important thing. To get to the second term, how often do I have to add on that difference? Only once, isn't it? Yeah, so if I want to get to the second term, I have to add on 11 once. If I wanted to get to the fifth term, I had to add on 4 lots of 11, didn't I, from the first term? So to get to the 20th term, I'd have to add on 19 lots of 11. So to get to term n, I have to add on 11, n minus 1 times, whatever term I'm up to. So to find the 50th term, we've now got a simplified rule which just says it's 11 times n minus 5. So we go, okay, well that's 11 multiplied by 50 minus 5. I don't know if we did them last year. Yeah, primary school we did sequences probably. So the 50th term, without having to find all the 49 in front of it, I can figure out that it's 545 without having to think. So it's pretty handy. Hello, Claire. That's 11. (11n minus 11). I did expand the brackets. What's spotted, Phoebe? You'll be a good maths teacher soon. Oh, as if you don't want to be a maths teacher when you grow up. She would what? No, that's right. You want to be a trophy wife, don't you? The only problem is that... Oh, I better not say it while we're recording. No. Don't encourage me, you know I will. Oh, I didn't say anyone's name. I said I can't say it. Let it go, let it go. No, you want to be a maths teacher, it's more fun. Is 325 a member? How would I check? Of the sequence. Yeah. Let it be one of the terms, and let's figure out... Will it be one of the numbers? That's the way to check, is just to let it be UN and figure out what term it would be. Too many conversations. So I need to add 5, so I've got 330 equals 11n. And then if I divide by 11, that's teal. 325 is the 30th term. Is 761 a member? I reckon you could probably guess the answer by now. Well, so I'll give you a minute to try and do that, and I've got a timer here, so you've got until 26:19. Lily's not going to make it. But there is one around here somewhere, yeah. I don't know why. Till it's 26:19, you're nearly there. See, now why do you think I'm guessing that it won't be without even having a think? Because the first one was, and it's unlikely that they'll give you two that both are, because I want you to practice both. That's my theory. Just thinking like the textbook, right? Doesn't work. Yeah, it didn't look like it was going to. You even had 18 seconds left over. That's good. 761 equals 11 and minus 5. Add 5. 7. Oh, learn to write, chewers. 766 equals 11n. Now, do you know your divisibility test for dividing by 11? Yes, if the sum of the odd digits is equal to the sum of the even digits or differs by 11, then, or a factor of 11, then they'll be divisible by 11. 7 and 6 make 13. They don't differ from 6 by 11, so it's not going to work. Or you could have just figured out 770 was the 70th term, so it's 4 less than that. So n is not an integer, therefore no. It is fun math. Yeah, blah, blah, blah. So we want to try a few of these. Yeah, let's do some harder ones. Let's do question 5. Or can we do 4? What about we do question 3 and then question 5? Question 3 looks good. I mean, all the numbers are obviously good. But, well, that's because you're still starting out, and, you know, we're pretty nice as maths teachers. You're going to have to learn to be a little bit nicer when you're a maths teacher. Just a little bit. You're pretty nice, but sometimes a little bit harsh. Whereas I'm never nasty or mean at all. I love this positive affirmation your friends are giving you. It's the same thing though. Oh, really? So you teach like Mr. Fan? That's right, we're recording all of this. I'll just play it back. He does like to tell it like it is. He tells it like it is. He knows he does. There's nothing wrong with that. I believe you would. Oh, really? Well, just pretend it hasn't. Just put it on pause. Catch up at lunch. Catch up at lunch. Put it on pause. What? What you didn't hear at lunch? They did, yeah. We all got told not to let students use their computers outside of class time in the locker area. Yeah, because you need to talk to real people, not talk online. And it's like, they're not talking, they're working. What is it? Ugh. Yeah. All right. I'm assuming you've all done it while I've been waiting. Yeah. Yeah. Has she? Oh, don't be like that. If you don't do my homework, you won't learn as much as the people who do. That's it. If you don't do my homework, then you won't learn as much as the people who do the homework. That's about it. Yeah, that's all that's going to happen. You'll learn more. Nah, well, that's not true. So, to prove that a sequence is arithmetic, all you've got to do is show that the difference between consecutive terms is constant. So if I take the generic un plus 1, following their hint, that's 3 times n plus 1 minus 2, and then I subtract un, which is 3n minus 2. If this ends up being a constant, then I know I've got an arithmetic sequence. So let's see, I've got 3n plus 3 minus 2 minus 3n plus 2. Well, 3n minus 3n cancel, I've got 3 minus 2 plus 2, 3. Oh. This is an arithmetic sequence. So, and just let me finish writing that, because otherwise I'll mess up my writing. Common difference of 3. So, un plus 1 is just the term that comes after un, isn't it? Yeah. Un is my general term, and my general term is 3 minus 2. If I have un, what would the term after un be? Wouldn't it be un plus 1? But the term after u4 is u5, after u76 is u77, so after un is un plus 1. So that's just the next term. And see, if I find the difference between any two consecutive terms, the answer is always going to be 3. I do not have a sharpener, I'm sorry. Just it's very well organised. Hello. There's one over there and one behind me. You said sir and then you didn't say anything. Why? Fair enough, you're just feeling bored. Find U1 and D. Well, we've already found D, haven't we? We found the difference between consecutive terms was 3, so that's easy. And find U1. Well, U1 is also easy. U1 equals 3 times 1 minus 2. Using our UN equals 3n minus 2. Substitute 1 in for n. So U1 is equal to 1. Okay? Not too bad. Can we find the 57th term? U57. Well, all I'm going to do is stick 57 in where there's an n, aren't I? Am I not? If I want to find the 57th term, I just let n equal 57 and solve it. 3 by 57 is 150 plus 21 is 171 minus 2, 169. You could, if you wanted to, without using their little shortcut formula, go back to our very generic formula, which was U1 plus n minus 1 times D, and we'll just prove this is going to be the same thing, just for our own satisfaction. 3 plus 56 multiplied by 3, that's 150, 168. Well, that doesn't equal the same thing now, does it? So what have I done? No, that does. Difference is 3. Oh, U1 is 1. That's why it doesn't equal the same thing. I just didn't write my numbers out correctly. One plus 168 is 169. So you can do it either way. What is the last term of the sequence which is greater than, or what is the least term of the sequence which is greater than 450? This is a good little question because it makes you exercise your brain a little bit. So UN, we want it to be greater than or equal to 450, was it? Am I getting carried away and going too quickly again? I will pause. So very exciting. So we're trying to find the least term, so the smallest term in the sequence. What number term is it? Like the 17th or the 80th or whatever, which is greater than 450. So I've got my expression for UN. UN is 3 times n minus 2. And I want to know when is it greater than 450. I think I should actually be doing greater than, not greater than or equal to there. Seeing as though that's what the question actually says. So let me, now that I've actually read the question more carefully. Well, that's right. 450 isn't greater than 450, so I'd have to sort it out. But we don't need to worry about it because 450 won't work. So I add 2 to each side, so I've got to find 3n is greater than 452. So n needs to be greater than 452 over 3. Which, if you want to write that, n needs to be greater than 150 and 2/3. No, it's the least term. So it's the smallest term that's bigger than 450. Because there's an infinite number that'll be bigger than 450. And we've got to find what U150 is, or U151. I don't like the way it always does those funny little dashes. I'm pretty sure I've got it right. If my 151st term is 451, that's the least member. That's the smallest member that's bigger than 450, isn't it? It's asking for the least term that's greater than 450. So what's the smallest number in the sequence that's still bigger than 450? And so when I find out that I need the term which is greater than, all the terms greater than 150 and 2/3 are going to be bigger than 450. All of them. So like the 1,000th term, the 1,000,000th term, they're all going to be bigger than 450. But the least of those, the smallest one out of all of those, would be the 151st. Because it's the smallest integer that's bigger than 150 and 2/3. So it's the 151st term. It's the 151st term, but that, will be greater than 450. That, I don't know, the 0 didn't write. Sorry, yeah. And so that's what it actually is. Because did the question ask us for what is the term? No, what is the least term? So I can write the 151st term, but I haven't actually said what the term is yet. So, well, how are you going to assume 451, not 452? Yeah, like it could be 459 or 4,716 if you have a really big difference. Like, yeah, you're better off just doing it that way. I want to have a go at something out of question 5 here, just to give us something to do. Whoa, can everyone read that? That might make it a little bit easier. Find K given the consecutive arithmetic terms. So they're telling you the sequences are arithmetic and they're asking you to find the value of K that makes it true. So, I might work through A for you and then give you a chance to do B. Does that sound cool? Alright. Here's how I would approach A. If it's an arithmetic sequence, the difference between terms is constant. So, if I took the second term and subtracted the first term, that would be the same as if I took the third term and subtracted the second term. Wouldn't it? If I take the second term, so what I've done here is I've got the second term and I've subtracted the first term. And that should be identical to if I did the third term minus the second term. Because for an arithmetic sequence, the difference between terms is constant. So we don't really need that line there. Let's just go back to what we were doing. So I'm going to add k to each side. So I've got 2k take 32 equals 3. I'm going to add the 32 to each side. 2k equals 35. Divide by 2, k equals 35 over 2. Or 17.5 or 17.5 if you want to like ugly numbers. So, I reckon you could use the same technique to do the next one. I'll give you a couple of minutes to try that one, and then we'll have a go. Yes, you probably would, but I don't think there are 4 terms in any of these. Alright, have a go, and then I'll do it in a minute. Alright, so let's see how we went. Second term minus the first term, so 2k plus 1. Remember to keep them in brackets when you do minus k plus 1. The difference between the second and first term should be the same as the third term minus the second term, so 2k plus 1 there. And now we're just going to solve it. So 2k minus k is k, and 1 minus 1, well, that disappears, equals 13 minus 2k minus 1. So it's 12 minus 2k. 3k equals 12. K equals 4. It's always nice that you've got time to check it. If you're in an exam, it's great communication, they'll love it. But maybe just go back and do that after you've finished or something. What would it be? 4 plus 1 would be 5. 8 plus 1 would be 9. And 13. Yeah, that's an arithmetic sequence. That's good. Next one. Second term minus the first term. K minus 5 equals k squared minus 8 minus k. Let's neaten that up a little bit. I've got k squared on the right, so I'm going to keep it there. I've got negative k. I've had to subtract another k, so that's minus 2k. Adding on 5, that'll give me minus 3. Let me just show the working there in case that was a little bit quick. What did I do? I said I wanted to add 5 to get rid of that 5, so I'm going to add 5 to the other side, and that's why negative 8 plus 5 is negative 3. And I needed to subtract k, so negative k, take away another k, that's where my negative 2k comes from. We're now experts at factorising quadratics, aren't we? K take 3, k plus 1. Therefore, k take 3 equals 0, or k plus 1 equals 0. What's that law? Null factor law, chewers. Oh, good. I'm not just talking to myself. I heard you, though. That was good. So, can we check it and see if it works? If k equals 3, what do I get? I get 5, 3, and 9 minus 8 is 1. Oh, yeah. That's an arithmetic sequence with a difference of negative 2. That works. Go away, please. Hide the keyboard. If k equals 1, what do I get? I get 5, 1, and 1 squared minus 8 is negative 7. That went down by 4, then it went down by more than 4, did I? Am I supposed to have negative 1? Yes, I just can't read my own writing. 5, negative 1, negative 7, going down by 6 every time. There you go, pretty easy. They're arithmetic sequences. We've got 20 minutes left. Do you want to just work, or do you want to see geometric sequences and do it all? Okay, we'll leave it there. That was fun.